Hi, very warm welcome to all of you on the Pulse video series. My name is Akhilesh and we are meeting here for geography. In today's class, we are going to discuss about the interior of the earth because there are certain factors that have led us to understand what exactly there inside the earth. Human curiosity led us to know more about the interior of the earth. And to understand the interior of the earth, we are not having so much of direct evidences. The direct evidences which can be tangible, which can be measured. So we are very limited in terms of direct evidences. Like if you see the direct evidence up to which we can drill inside the interior of earth is nothing but just 12 kilometer in Kola region, the deep ocean drilling project. 12 kilometer is very less as compared to the radius of the earth, which is approximately 6400 kilometers. So knowing just 12 kilometer stretch is not going to make you understand the entire model of interior of the earth. Apart from it, there are other, what you can say, direct evidences through which we can have some understanding, but they are not going to be sufficient enough. That's why we started pursuing some indirect evidences. You will find in your notes, it has been mentioned in your notes that there are direct evidences which is not giving us a good amount of information regarding the interior of the earth. Then we started pursuing some indirect evidences, and in which we can have the first evidence in form of temperature. Temperature. Fine. So it was observed that the temperature of the earth is increasing when we go inside. So as we start moving inside, there was increase in temperature. There was an increase in temperature. It was observed that this increase is by 1 degree centigrade after every 32 meter depth. 1 degree centigrade increase in temperature after every 32 meter depth. If this is the case, can you calculate the temperature at the center, 6400 kilometer? If this temperature is increasing at this much enormous rate, certainly at the center of the earth, we happen to have temperature which is approximately 2 lakh degree centigrade. And if it is the case, then what happened? Earth will not remain in its original form, which is what? The solid state. That means, yes, there is an increase in temperature, but this increase is not of this rate. This increase is there up to certain level. Beyond the increase in temperature, rate of increase in temperature get decreased. And by tomographical scan, it was zero in that the core temperature is approximately 5300 degrees centigrade only. If you go with this increase, certainly it should be almost 2 lakh degrees centigrade, which is not possible. But why there is an increase in temperature? This should be a question. So there are 4 reasons that has been given that why the increase in temperature taking place. Reason number 1 is what? The residual heat. The residual heat. This residual heat is something which was given at the time of formation of the earth. And the outer crust dissipated this heat, but what happened? The mantle, outer core and inner core still having that heat, and slowly and gradually this heat is getting dissipated. So this is the reason why the core is at high temperature followed by outer core as well as mantle. So you'll find that the core is having almost 5300 degree centigrade temperature, while outer core is 4000 to 4500 degree centigrade temperature, while the mantle is from 900 degree centigrade temperature to 2200 degree centigrade temperature. And inside the core, you will find the fluctuation of temperature. From on the surface, it is just 15 degrees centigrade. And then we start moving down, there is an increase in temperature. This increase is attributed to this residual heat. Okay, this residual heat is something which was given to the earth at the time of formation of the earth. ना वो heat बची हुई है और बाहर से there was dissipation of heat slowly and gradually. The outermost layer get cooled, solidified, and stratification of earth. We have seen it already. Second thing, there may be presence of dry rocks. Dry rocks. Dry rocks are those rocks which has abundance of radioactive element. Radioactive element. These radioactive elements are known for radiation. Which kind of radiation? Alpha, beta, and gamma radiation. And these radiations are responsible for heating effect. Heating effect. Fine. So, when we are going inside the interior of the earth, in the crustal rock, there are certain rock in a specific region which is very rich in radioactive elements. Suppose that this is the rock which is having lot of radioactive elements. Fine. These are the rocks that happen to be called as dry rocks. These rocks are having abundance of radioactive elements. Okay. These are dry rocks. Fine. And because they have radioactive element, so there is continuous emission of radiation, alpha, beta, gamma radiation. And these radiations are responsible for heating effect. So the surrounding area of these dry rock is going to be heated. And this is the reason while we are moving down, we find there is an increase in temperature. So they are the dry rocks, presence of dry rock that is containing radioactive element. May be possible, the third possibility of increase in temperature is explained like the rocks contain mineral. Obviously, the rocks are made up of mineral. Fine. These are the crustal rock, and these crustal rock are containing mineral, and some of the rock having mineral undergoing chemical reaction. There may be chemical reaction inside the rock. Fine. These rocks are made up of mineral, and mineral undergoing chemical reaction. Undergoing chemical reaction. Fine. And this chemical reaction is of exothermic type. This is what? Exothermic type. When there will be exothermic reaction, what is the meaning of exothermic reaction, dear? Exothermic reaction is that chemical reaction in which two chemicals are combining with each other, reacting with each other and forming certain product, and in the process huge amount of energy is released, heat is released. That's why exothermic. So when A and B combine to form C and there is release of heat, then it is going to be called as exothermic reaction. For example, if you put sodium inside the water, फेंक दीजिएगा, हाथ अब रखिएगा मत, you will find that exothermic reaction is taking place. So what happened when this kind of reaction is taking place? The surrounding area get heated up. surrounding area get heated up, and this will cause heating effect. Heating effect. Fine. And due to that, while we are moving down, we find that there is increase in temperature. Increase in temperature. It was observed that this increase in the crustal rock is almost 1 degree centigrade after every 32 meter, but later beyond the crust, the rate of increase was decreased, and hence what happened, up to core, you are going to have temperature of 5300 degree centigrade. The fourth reason of rise in temperature is what? Pressure of overlying rock. Pressure of overlying rock. Okay. Pressure of overlying rock. These are the crustal rock, and as we go down, we find that the pressure exerted by the overlying rock is going to be massive. And due to this overlying rock pressure, you will find that there is increase in temperature. Increase in temperature. So these are the four explanations why there is an increase in temperature while moving inside the earth. Fine. Then let's come to density of the earth. Density. Meaning of density is what? Distribution of mass per unit volume. Density is what? Distribution of mass in per unit volume. What happened? The earth crust is what? Tangible. This is crust. Hence, the earth crust density was measured already. भाई आपके पैर के नीचे जो rocks हैं उसकी density आपने average density नाप ली थी. And it happened to be 2.57 gram per cc. This was the density of the crust. Fine. And after discovery of gravitation, Newtonian principle, there was a scientist Cavendish. He measured the average density of the earth. Average density of the earth. And on the very basis of Newtonian principle of gravitation, the density was measured, and it was found that the density happened to be 5.5 gram per cc. This is the average density of the earth. So and it is almost twice the crustal density. Okay, ये theoretically ये calculation हुए थे. And when this density was enormously high, then people have understood कि यार यहाँ इतना सोना है तो अंदर कितना होगा. That means a curiosity cropped up, and then we started exploring that what exactly is there inside the interior of the earth. And then density was measured by so many, what you can say, indirect sources. Now we have tomographical scan, and we can go for tomographical scan. These are the throughput technology through which we can measure the density as well as temperature of the interior of earth. But yes, this density was measured on the very basis of seismic wave. In later phase of the class, you will get to know. Apart from it, we have volcanic eruptions. Volcanic eruptions, the type of composition, we can determine that this lava is made up of these mineral. But the thing is, at what depth this lava is coming, and it is not going to tell the entire story, rather it is giving you the fragmented story, isn't it? So we are having the chemical composition of lava, chemical composition of magma or lava. We have density of it. Okay, we can measure the temperature of it, but they are fragmentary. They are not giving you the exact idea how the interior is going to be arranged. Not only this, we have, let's say, meteoritic fall. Meteoritic fall. Okay. So certain meteorites were observed and they were analyzed. So yes, we have the chemical composition, and because we all have the idea that everything in the universe has been formed from the same process of sustained fusion reaction, which we have discussed in the Big Bang theory. That means whatever the chemical composition of meteorite, certainly it will be the it may be the chemical composition of Earth, and so many things are going to be similar over there. Fine. But all these stories are not giving you the concrete, what you can say, insight about the interior of the Earth. We require certain gems bond which can go inside the Earth interior and come out and tell the entire story. That's why the indirect sources are going to be more, what you can say, reliable to understand the interior of the Earth. In pursuit of that, we have reached to the what you can say, seismic wave, and these seismic wave have given the beautiful story of the interior of the Earth. But yes, this seismic wave is not going to give you the entire story easily. We have to observe it and we have to analyze all those, what you can say, shadow zone as well as different earthquakes and their information, data analysis, and after lot of Herculean task, we have deduced the model of interior of the Earth. So let's come to the real story, how we have concluded that yes, there is crust, mantle, core, outer core, etc., discontinuities and all. It is solely based on the seismic waves. Fine. So how the seismic waves are going to be pivotal in determining the interior of the Earth, we are going to learn it. Fine. So let me explain the seismic wave first, because without knowing the characteristic of your agent, how come you can understand which way the cat will jump? Okay. That's why we need to understand the seismic wave first. So there is a point inside the interior of the Earth from where the energy released due to one or another reason, maybe tectonic activity or maybe something else, then this energy start traveling onto the Earth's surface in all direction. Okay, and they reach onto the surface of the Earth. The point at which the seismic wave arrive is called as epicenter. It's called as epicenter. Epicenter of the Earth. While the point from where the earthquake have started is called as hypocenter of the Earth. Hypocenter of the Earth. Fine. Energy start travel in form of body wave. Fine. So we have two type of seismic wave. Seismic wave. Energy travel in form of seismic wave. One is called as body wave. Body wave. And another one is called as surface wave or skin wave. Surface wave or skin wave. Fine. Different name has been given by different authors, so it's not going to make any difference. But yes, sometime they used to ask question, दूसरा नाम दे के पूछ देते हैं तो लोगों को लगता है ये क्या आ गया, इसलिए नाम अलग अलग होते हैं. जैसे टॉर्नेडो का ट्विस्टर दिया हुआ है बच्चे, तो same thing is there, but the twister is new name. That's why try to put all those name, possible name जो कि पूछे जा सकते हैं. Body waves are those wave, they travel inside the body. They travel inside the body. These are the body wave. Fine. Inside the body of the Earth. Body of the Earth. While the surface wave generated because of the redistribution of energy. Redistribution of energy brought by the body wave. So these body wave bring the energy onto the surface, and there is redistribution of energy, and this redistribution of energy give rise to surface wave, and surface wave start moving in the surface of the earth, on the surface of the earth, on the skin of the earth. So these are called as surface wave. Surface wave. How the surface wave arises? Surface wave arises because of redistribution of energy, redistribution of energy brought by body waves, brought by body waves. Fine. Redistribution of energy. So from hypocenter, the energy start traveling in all direction. It's not like yahi. It is start traveling in all direction. Start traveling in all direction. Fine. But where it reaches first is going to be called as epicenter. Fine. Hypocenter is the place from where the earthquake have arisen. This is also termed as focus of the earthquake. Focus of the earthquake. Is it okay? Now what? We have two type of surface wave and two type of body wave. This body wave is going to be pivotal to determine the interior of the earth. I'm coming on that, but before that I would like to give you some tidbits regarding surface wave. So this surface wave, they are slowest moving seismic wave, and almost the speed is going to be 3.5 kilometer per second. Okay, they are traveling in the skin of the earth, in the surface of the earth, and they are going to cause devastation. So massive destruction on the earth's surface is basically caused by these surface wave. These surface wave is of two types. One is love wave, or it is called as L wave. It was discovered by A.E.H. Love. Hence the name has been given love. Otherwise, इसका love से कुछ लेना देना नहीं है. It is what most disastrous seismic wave. Love wave. Another wave is called as R wave. R wave or relay wave. Relay wave. Fine. R wave or relay wave. Is it okay? So, love wave as well as relay wave, they are surface wave, and both are going to inflict massive destruction because of earthquake. And why they are causing massive destruction? Because they cause oblique motion in human infrastructure. So how they are traveling on the surface, and due to that they causes oblique motion. For example, what is the meaning? Let me explain it. Suppose that you are having this building, this vertical structure is having a building. मान लो अच्छा तो नहीं बनाया, but फिर भी ठीक है. Anything which is going to cause vertical movement, means थोड़ा ऊपर चला जाए, थोड़ा नीचे चला जाए. This is vertical movement. So what happened? The center of gravity will remain at the center. That means it is not going to be fluctuated. But what happened if this is going to have an oblique motion? Oblique motion like this. Oblique motion is like this. So oblique motion, sidewise motion, it is because of surface wave. That's why what happened, the center of gravity, this will remain over here, और ये जब इधर उधर चला जाएगा तो it will cause what? Destruction or collapse of buildings. Collapse of buildings. And do remember, these surface wave remain for longer duration in unconsolidated landmass. So unconsolidated. If the land is unconsolidated, for example, alluvial plain हो जाए आपको, alluvial plain, क्या होगा बच्चे? Unconsolidated landmass. So in such landmass, this surface wave remain for longer duration. In such landmass, it will inflict more tremors and hence more destruction. If you see the Bihar earthquake of 1934 as well as 1989, you'll find Bihar is what in middle Ganga plain. There is lot of destruction because of these what you can say surface wave, and that is due to unconsolidation mass. Because in unconsolidated land mass, it will remain the seismic wave, the surface wave cause what you can say tremors for long duration. They remain active for longer duration and inflicting more damage. Fine. And if the land mass is consolidated, बेसाल्ट की रॉक है, ठीक है बच्चे. जैसे आप देखोगे ना, सेस्मिक जोन इंडिया को डिवाइड किया गया है 4 सेस्मिक जोन में. जोन 5 जहां पे सेस्मिसिटी सबसे ज्यादा है, सो द इंटायर हिमालयन स्टेट, नॉर्थ ईस्ट, Andaman and Nicobar, and some area of what? Bhuj, sorry, not Bhuj, it's Kutch region of Gujarat. This is what in zone 5. Then there is zone 4, zone 3, and zone 2. I'm talking about zone 2. Zone 2 of India is going to have least affected by the earthquake. Fine. So if you see the zone 2 in your map, you will find it is the most stable block, and that is what not unconsolidated, rather they are consolidated block made up of basalt as well as what you can say, that means Dharwad system is there. Then we have Chota Nagpur plateau area. तो ये क्या है बच्चे? यहाँ पे least seismicity है. And what about Ganga plain? It is in zone. Means if northern Ganga plain you are talking about, it is in zone 4. Otherwise, it is in zone 3. That what is the reason behind it? Because of the unconsolidated mass will be more what you can say shaky due to the surface waves. Fine. इसकी चर्चा हम लोग अर्थक्वेक में और बेहतर तरीके से करेंगे. अभी फिलहाल हम लोग फोकस होते हैं इंटीरियर जानने पे. तो आइए बात करते हैं बॉडी वेव्स की. सो लेट्स डिस्कस बॉडी वेव. बॉडी वेव that travels inside the body of the earth, and again it is divided into two types. One is called as primary wave, and another one is called as secondary wave. Fine. Primary wave as well as secondary wave. Okay. Let me explain this primary wave, why it is called as primary. So primary wave is first seismic wave arrived at the epicenter. जब दौड़ लगी ना सेस्मिक वेव की, तो प्राइमरी वेव सबसे पहले पहुंचने वाले वेव्स थे. ठीक है. दे आर फर्स्ट टू अराइव. व्हाई दे आर फर्स्ट टू अराइव? बिकॉज दे आर द फास्टेस्ट seismic wave, and they have a speed of 5 to 15 kilometer per second. This is going to have the speed 6 to 15 kilometer. Please correct it. 6 to 15 kilometer per second. They are the fastest seismic wave. Fine. They are first to be recorded at epicenter. They are mechanical longitudinal wave. They are mechanical longitudinal wave. What is the meaning of mechanical wave? Mechanical is those waves that require medium. Without medium, they are not going to travel. So, in wave optics या फिर आप जब wave पढ़ते हैं physics में तो आपको बताया जाएगा two types of waves are there. One is electromagnetic wave, another one is mechanical wave. Electromagnetic wave do not require medium, जैसे हमारी light, so it can travel even in vacuum. But what about this mechanical wave? They require medium, and it is of two types: mechanical longitudinal wave and mechanical transverse wave. What is the meaning of longitudinal wave? Let me explain this. Fine. So when the wave is traveling, there is oscillation in the medium particle also. The medium particle oscillate along the direction of wave propagation. Then we call it it is longitudinal mechanical wave or mechanical longitudinal wave. How it can be determined? So suppose that this is the direction of wave propagation. Direction of wave propagation. Direction of wave propagation. And if the medium particle oscillates in the direction of wave propagation, then we call it mechanical longitudinal wave. Mechanical longitudinal wave. I am representing the compression and rarefaction. That is what the oscillation of medium particle. So what happened? There is compression and then there is rarefaction. Compression, rarefaction. Compression, rarefaction. And so on and so forth. So you'll find there is compression, the medium particle compressed like this, then rarefaction, compression, rarefaction, compression. Try to understand the movement of my hand. There is compression, rarefaction, compression, rarefaction, compression, rarefaction. This is how the wave is moving. In which direction? This is the direction of wave propagation. And these are the oscillation of medium particle, compression, rarefaction. So when the medium particle oscillate in the direction of wave propagation, it is going to be example of mechanical longitudinal wave. Mechanical longitudinal wave. Medium particle oscillates in the direction of wave propagation. Fine. For example, such waves are going to be there like sound wave. Sound waves. Yes, sound waves are example of mechanical longitudinal wave. They are moving like that. There is compression, rarefaction, compression, rarefaction, compression, rarefaction. Fine. And this is the reason at the time of earthquake, if you have experience of earthquake, when there is earthquake strike, you will hear a grunting sound just beneath your feet, as if there is a huge machine is moving inside the crust, isn't it? वो जो साउंड आता है, गर्जना जो आती है earthquake की, that is what the signal that there is arrival of what? This primary wave. So at the time of earthquake, we hear we hear a peculiar sound just below our feet is due to primary wave, primary wave. Fine. And this primary wave can travel in all the medium. Primary wave, it can travel in all the medium. Primary wave can travel in all the medium. It has been observed that on increasing density, their velocity get increased. On increasing density, there is an increase in velocity. For example, if you see the sound wave in air, they have the speed of 332 meter per second. What about in steel? More than 1100 meter per second. Have you seen that na? In class 6, 7th, 8th, आपने पढ़ा होगा कि ट्रेन की पटरियों पे कान लगा के सुनो तो आवाज ट्रेन के दिखने से बहुत पहले आ जाती है. क्यों? क्योंकि लोहे में या स्टील में ध्वनि की चाल अधिक होती है. So on increasing density, what happened? Their velocity get increased. We are talking about this primary wave. It can travel in all the medium, in solid, liquid as well as gas. They are also called as P waves. ना इनको P wave कहा जाता है. They are also called as P wave. If I ask to you why it is called as P wave, most of you will reply कि sir, it is due to primary. तो short में उसको P wave, जैसे मेरा नाम अखिलेश चंद्र है तो you can call me AC, isn't it? लेकिन ऐसा नहीं है. मेरे साथ तो ठीक है AC बुला सकते हो. इसे प्राइमरी के कारण P wave कहोगे तो ये नाराज हो जाएगी. So it is not because of primary, but because of its intrinsic nature. It's not, this P is not taken from primary. Rather, it is going to be called as P wave because of its intrinsic nature. And the nature is what? It is push wave. It exerts pressure on the medium. Pressure wave. So it exerts pressure on the medium, just like the sound wave. I'm speaking over here, the sound, although you are listening me from your board, or you can say your gadget, otherwise in front of me if you are there, so I produce this sound, it is going to hit your tympanum membrane, it will vibrate, and according to the vibration your mind will understand कि कौन सी भाषा मैं बोल रहा हूँ. So this push creating wave or pressure creating wave, and that's why it has been given this name, that is what? P wave. So it exerts pressure, it creates push, and that's why it has been given this name, that is what? P wave. It can travel in all the medium. Fine. Let's come to the S wave. S wave or secondary wave. Again, secondary wave को S wave secondary के कारण कहते हैं कि नहीं, आगे देखेंगे. ठीक है. Secondary wave. They are called as secondary wave because they are the second contender to arrive at epicenter. They are second at epicenter. तो ये second क्यों हुए? क्योंकि they are slower than the primary wave. So their velocity is less than primary wave, ranging between 5 to 7 kilometer per second. 5 to 7 kilometer per second. पर आवर होता तो क्या ही बात होती. अर्थक्वेक आने वाला होता, हम लोग चाय पकौड़ी करके बाहर निकलते, है कि नहीं. सो पर सेकेंड याद रखिएगा. So velocity 5 to 7 kilometer per second. Is it okay? They are mechanical transverse wave. They are mechanical transverse wave. What is the meaning of mechanical transverse wave? That medium particle oscillate perpendicular to the direction of wave propagation. If this is going to be the direction of wave propagation, then medium particle oscillate perpendicular to the direction of wave propagation like this. There will be upward movement. There will be downward movement. Up and down. So direction of wave propagation and oscillation of medium particle, both are going to be perpendicular with each other. Fine. These are called as mechanical transverse wave. If you compare this mechanical transverse wave, you can easily find out the wave which is on the surface of the water. So if you see the surface of the water, you'll find this mechanical transverse wave. So if you are creating any turbulence in the water, you'll find that turbulence is moving in all the direction in form of ripples or in form of waves. Okay, so it looks like this. You'll find these are the crest and trucks, and this is how the waves are moving. But what about the oscillation of water molecule? On the surface I'm talking about, it looks like it is moving up, then down, moving up, then down. But in holistically, if you see the movement of water, there is a circular movement basically. ना जब सुनामी पढ़ाऊंगा तो आपको बताऊंगा, या वेव पढ़ाऊंगा then I will tell you. So there is a circular movement. The water is executing a circular movement and propagating just like the wave. Na? This is what wave of ocean. But once you are watching just this part and this part, you will find there is upward movement, downward movement, upward movement. But in entirety, you will find that the water is moving in a complete circle. It is moving in complete circle, and there is transfer of energy from one circle to other circle. And this is how the energy transferred towards the coast. और कोस्ट पे पहुंच के सुनामी वगैरह बनते हैं, आगे कहानी बताऊंगा. बट द थिंग इज कि द सरफेस वाटर वेव इज सिमिलर जस्ट लाइक द सरफेस वेव, and that this secondary wave, that is what mechanical transverse wave. This is representing direction of wave propagation. Direction of wave propagation, and this represent oscillation of medium particle. Fine. Further, this secondary wave cannot pass through. Secondary wave can travel only in solid medium. Only in solid medium. It gets seized in liquid medium. Fine. Next thing is that it is called as S wave. It is also called as S wave. My question is why? This S represent its nature. What is the nature of this wave? It is a shear producing wave. Shear producing wave. It is a shear producing wave. It produces shear in the medium. What is the meaning of shear? Tangential force is called as shear. Suppose that this is the medium upon which a wave is going to produce the shear. Shear producing wave. This is a medium and the wave is coming like this. It tried to produce shear over here. And if the medium is going to be like that, there is no deformity. So what happened? This wave travel in the same way like this. And it can pass through it. Fine. So this is what S wave is, shear producing wave. And it tried to produce shear and there is no deformity. No deformity, that means the wave is in continuity through the medium. Then this wave will pass through it. This is what? Medium. Okay. So if I give you a block of solid iron and you try to produce shear, can you deform it? Answer is no. Fine. So this is what medium, which is going to be solid. But what if this shear producing wave is going to cross a medium which is unconsolidated, loosely held, like water? So what happened? This shear producing wave will come like this and try to produce shear in this medium. And due to the shear effect, there will be deformity. Okay. And this deformity is like this. There is a deformity. Water get displaced like this. Okay. And this deformity will absorb all the energy associated with this shear producing wave. All the energy. It's liquid medium. Fine. This is liquid medium. Okay. So this liquid medium get deformed. The wave is producing shear and due to this shear, there is deformity. There is deformity. And what happened? The energy associated with this shear producing wave get dissipated in creating deformity. So जब energy ही खत्म तो will it cross the medium? Answer is no. This is the reason why S wave cannot pass through liquid medium. ठीक है बच्चे? So ये add कर लीजिएगा. It is not able to cross the liquid medium because they are shear producing wave. They produce shear and due to shear there is deformity. And in creating this deformity, what happened? The entire energy get dissipated. So they cease to travel through liquid medium. That's why they are not able to cross the liquid medium. What happened here? They try to produce shear, but there is no deformity. Okay. So energy conserved over here and that's why this energy will travel through the solid medium. If this medium is solid, so this wave can travel through it. Otherwise, in case of liquid medium, it is going to produce shear, there will be deformity, energy associated with it get dissipated. Fine. जैसे मैं आपसे कहूँ कि hit me in my tummy. आपने खींच के एक दे दिया, मैं वहीं बैठ जाऊंगा, है कि नहीं? लेकिन मैं कहूं कि आशीर्वाद आटे की 10 किलो की बोरी ले आइए, उसको गूंथ लीजिए, गूंथने के बाद फिर मुझे दे दीजिए और मैं ऐसे पकड़ लूं. अब मैं आपको नहीं, माइक टाइसन को बुलाऊं कि चलो आओ हिट करो. तो वो जब मुझे हिट करेगा उस पेट पे नहीं, उस डग पे जो अभी हमने बनाया है, तो उसके पंच से डग क्या होगा, डिफॉर्म होगा बच्चे, और मुझे कोई असर नहीं होगा. वाई? बिकॉज द एनर्जी एसोसिएटेड इन द पंच get dissipated in creating the deformity, isn't it? And that's why I will not be affected at all. And the same way, if he hit me without that medium, what happened to me, you can easily understand. So this is what the story of shear producing wave. Is it okay? So S wave cannot pass through liquid medium. ये सारी जानकारियां मिल चुकी थी. अब बारी थी इन जानकारियों से जो ऑब्जर्वेशन मिले उन्हें जोड़ के देखने की. तो आइए चलिए सीखते हैं वो ऑब्जर्वेशन जिससे हम जान पाए कि अर्थ का इंटीरियर कैसा होगा. ठीक है बच्चे? सो द ऑब्जर्वेशंस मेनली क्या था बच्चे कि देयर वेयर, मींस इफ यू सी दिस इंटायर वर्ल्ड, वी हैव नॉर्दर्न हेमिस्फीयर, southern hemisphere, 90% of land is there here, 10% over here. That means the countries are over here, and there is seismic event, and all the countries having in their district headquarters having at least one seismograph. That means numerous seismographs are there on the surface of the earth, and any seismic activity is going to be recorded. Fine. And what happened in any seismic activity, when these body waves start travel, it will reach to everywhere. It must reach to everywhere. Okay, and it was recorded. With respect to the hypocenter or the focus of the earthquake, the distance is known कि कितना distance चलना पड़ेगा, and there were, what you can say, lakhs of earthquake every year, and hence lakhs of observation every year through which we can go for data analysis. And after that data analysis and observation, we have deduced the model of interior of earth. So what were the observation? Let me explain it. So observation were shadow zones. Shadow zone. So two shadow zone were observed. One was P wave shadow zone. P wave shadow zone. Okay. What was found that for each seismic event, this is what focus of the earthquake, this is the center of the earthquake, this angle is going to be 90 degree. ठीक है बच्चे? So focus and center, with respect to focus center, this angle is going to be measured. And what happened when the primary waves were recorded, it was found everywhere like this, it travel everywhere, and all the seismograph have recorded it. It was recorded, but beyond 103 degree. Beyond how much? 103 degree. Beyond 103 degree. P waves were not recorded. Sorry, P waves, बस एक मिनट 103 degree and 143 degree. 103 degree and 143 degree. In some book it has been mentioned 105 degree and 145 degree. It hardly matters. The thing is angular distance is going to be of 40 degree. याद रखिएगा. क्या हुआ बच्चे? The P waves were not recorded in this zone between 103 to 143. Between 103 to 143, there was no P wave recorded. Then beyond it, again the P waves being recorded over here. So what is the P wave shadow zone? The P wave shadow zone is going to be this area, 103 to 143 degree. 103 to 143 degree. Both the side, this P wave were recorded, but between this 103 to 143, they were not being recorded. They were not being recorded. Beyond 143, again the P wave were recorded. So P wave shadow zone, this is the area which is called as P wave shadow zone. And do remember, this is event 1. And suppose that there is another event that have taken place like this. Suppose that there is another seismic event that have taken place over here. Okay, this can also be possible. This is center of the earth. Here it is going to be 90 degree. This is 103, 140, 103 degree, 143 degree, 103 degree, 143 degree. So the shadow zone was like this. Let me show you, because most of you get confused कि सर क्या ये longitude है कि latitude है, ये दोनों में से कुछ नहीं है, ठीक है? It is the angle with respect to the center of the earth and the focus of the earthquake. Do remember. बहुत सारे, मैं खुद confused था जब पढ़ा था पहली बार, है ना बच्चे? So you will find that everywhere you happen to have this P waves. P waves were recorded everywhere, but between 103 to 143 no P waves were recorded, and then after 143 degree again the P waves were recorded. So this is for event E2, and there are numerous such event, and we have found that P wave shadow zone is in between. This is going to be the P wave shadow zone. This area is going to be P wave shadow zone. So when you are going to have a conclusive result every time, same result every time, in all the 1 lakh seismic event in 1 year, तब तो कुछ सोचने की बात बनती है. इसका मतलब यहाँ कुछ ऐसा है अंदर जिसके कारण P wave will get deflected. तो पूछा गया भाई P wave ऐसा क्यों कर रहे हो? तो P wave ने बताया कि there is sudden change in density near about 2900 kilometer below the sea level. Sudden change, and this density change is going to be enormous. And due to that, our velocity get increased, and hence we get deflected from our original path. And that's why we always deviate for 40 degree, and we are not being recorded between 103 to 143 degree on the Earth's surface. Again, because we have crossed this medium over there, so we have reached to this area which is beyond 143 degree. So what was deduced from the means about the interior of the earth is, it was like there is something having very high density, somewhere at 2900 kilometer area, 2900 kilometer below the earth. Okay, somewhere 2900 kilometer below the earth. ये कैसे बताया गया होगा बच्चे? On the very basis of distance travel upon time elapse. और कई सारी घटनाएं हुई होंगी, यहाँ से यहाँ तक का टाइम ड्यूरेशन कितने समय में आया, एंड ऑल दैट. दैट इज नॉट द पार्ट ऑफ योर स्टडी, बट द थिंग इज यू नीड टू अंडरस्टैंड. फाइन. तो अब क्या होगा बच्चे, यहाँ पे जब सिस्मिक वेव आए होंगे, ऑब्वियसली यहाँ तक तो आए होंगे सारे के सारे सिस्मिक वेव, they will come like this, but they get deflected. They all get deflected like this. They all get deflected, and due to this deflection, they are not able to reach between 103 to 143 degree. Why this deflection was there? This deflection was there because of change in density, enormous change in density. So what kind of enormous change in density? When it was calculated, it was found at 2900 kilometer below the Earth's surface. Kilometer below the Earth's surface, there is a change in density that takes place is from 5.5 gram per cc to 11 gram per cc, 11 to 12 gram per cc, almost double. और इसी कारण से this P wave shadow zone were formed. This is one P wave shadow zone with respect to E1, that is seismic event. This is another P wave shadow zone with respect to E2. And there are lakhs of seismic event every year, and we happen to have so many data. These data were analyzed and this information was zeroing. Fine. कहने का मतलब आउटर कोर के बारे में पता चला, आउटर कोर या कोर का पता चला, क्योंकि अंदर क्या है, निकेल है और आयरन है. ठीक है बच्चे. डेंसर मटेरियल infiltrated near the center because of the rotation of the earth. If you remember the class of stratification of earth, I have given this information to you. Sustained fusion, heavy metals, and they get accumulated at the center. There was formation of what you can say, core as well as outer core. सेकंड है बच्चे एस वेव शैडो जोन. एस वेव शैडो जोन. एस वेव शैडो जोन, इसमें क्या ऑब्जर्व किया गया बच्चे? इट वाज ऑब्जर्व्ड that for each seismic event, there is, suppose that this is the hypocenter, here it is the center. Let me draw the angle first. So you just join it, and this is what representing 90 degree. Okay, here it is 103, this is 103. Okay, from here the P waves started radiating in all the direction. The P waves are moving like this, and they have been recorded everywhere. They have been recorded everywhere. These are the these are S wave, not P wave. गलती से बोल गया हूँ. Please correct it. S wave were recorded everywhere. This is 103 degree. Here also 103 degree. S waves were recorded everywhere, but they are ceased to be recorded. Beyond 103 degree, they are ceased to be recorded. No S waves were recorded in this zone. ये बड़ी बात थी कि भाई S wave तुम लोग आए क्यों नहीं यहाँ? And for each event, means this is E1, E2, E3, 1 lakh event, such kind of observation was found. तो पूछा गया S wave तुम आए क्यों नहीं? तो S wave बताए अपनी कहानी. क्या कहानी बताते हैं? Let me explain it. They explain the story why they are not able to come. They said, we encountered such medium that doesn't allow our passage. वाकई अच्छा. तो क्या हुआ? कहा कि अंदर जब हम पहुंचे तो हमें ऐसा मीडियम मिला जिसको हम क्रॉस नहीं कर सकते थे. तो वह कैसा मीडियम मिला? कहा सर लिक्विड था. Liquid medium, and we are shear producing wave, and as we reach in that liquid medium, our shear producing nature created deformity and we cease to pass. We reach over there But as we reach, we have produced deformity. And this deformity dissipates all our energy like this. So deformity was created. An entire energy get dissipated. So we are not able to cross this liquid medium. और कहाँ ऐसा हो रहा था? कहाँ सर? 103 के आसपास आप देखिए, एंगुलर डिस्टेंस यही थी, आप गहराई का अंदाजा लगाइए तो हुआ 2900 किलोमीटर below the earth surface. So as wave shadow zone gave idea about outer core. आउटर कोर के बारे में तो पता चल ही गया था, बट दिस आउटर कोर इज इन liquid state where it is situated somewhere below 2900 kilometer from the earth surface. These were the observation, and on the very basis of these observation, interior of the earth was deduced. And today we are going to have a model of interior of earth, the complete model of interior of earth, and which is actually deduced on the very basis of these observation as well as tomographical scan. Fine. So let me explain the interior of the earth. Fine. Let's have the interior of the earth. The interior of the earth can be broadly divided into crust, mantle, outer core, and core. Crust, mantle, outer core, which is liquid in nature, outer core, and core. This core and outer core is made up of Nephe, iron and nickel. This crust is made up of Sial and Sema. And mantle is largely made up of magnesium and iron. Fine. Further, when you see this crust, you can divide it in form of outer crust and inner crust. Okay, our upper crust and lower crust. Then you will find that there is a area of mantle which is part of this crust, and collectively we call it lithosphere. So the crust plus upper part of mantle, small part of mantle, is called as lithosphere. And this lithosphere is actually floating over a layer that we call as asthenosphere, which is in mantle. No? Basically, which is the part of upper mantle. Asthenosphere. Okay. This mantle can also be divided into upper mantle as well as lower mantle. Fine. And then there is outer core and inner core. Broadly, this is going to be the interior of the earth. We are going to have some more, what you can say, understanding about this crust, mantle, core, outer core, and the role of different layer. Okay, so let me explain this. So when we talk about the crust, we have two type of crust. One is upper crust, that is made up of silica and aluminium. That is made up of silica and aluminium. This is what upper crust. Okay. And there is lower crust also. Lower crust, which is made up of silica and magnesium. Here it is upper crust. Okay, so let me write it: upper crust, silica, aluminium, lower crust, silica, magnesium, Sial and Sima. And if you find this crust, you will find that there are area which is having ocean basin, and continent. So we will get continental crust, as well as oceanic crust. Continental crust as well as oceanic crust. If you see continental crust, largely it is made up of upper crust. Continental crust, thickness of continental crust, average thickness happen to be 30-35 kilometer. This is the average thickness of continental crust. But yes, sometime this continental crust may extend up to 100 kilometer. Mostly below the folded mountain series. For example, below Himalaya, you happen to have more than 70 kilometer thickness of the crust. And this is the reason, despite of being at destructive plate boundary, Himalaya do not have volcanic eruption. क्योंकि volcano को निकलने के लिए जगह ही नहीं मिलती. The thickness of the crust. Fine. So continental crust is what? 30 to 35 kilometer on an average, while the oceanic crust is 5 to 8 kilometer. 5 to 8 kilometer in thickness. But yes, simultaneously, if you see, oceanic crust is going to be denser. Okay. Why it is going to be denser? Because the lower crust of ocean is going to be thicker. The oceanic crust is largely made up of lower crust, while continental crust is largely made up of upper crust. यहाँ देखें आप lower crust का amount कम है. ठीक है बच्चे? So you'll find this kind of density difference. If you see the density, you will find that in upper crust we have 2.57 gram per cc. This is going to be the density, while the lower crust is having higher density of 3 gram per cc. 3 gram per cc. Okay. Oceanic crust and continental crust. Oceanic crust thinner है but higher density है बच्चे. Why? Because of Sima layer, silica and magnesium. Okay. There is a discontinuity between upper crust and lower crust, and this discontinuity is called as Conard discontinuity. Let me show you this Conard discontinuity. This Conard discontinuity is in between upper crust as well as lower crust. Upper crust as well as lower crust. Upper crust and lower crust is having this Conard discontinuity. Conard discontinuity between upper crust and lower crust. Is it okay? Just below this crust, there is mantle, and the part of upper mantle associated with lower crust constitute lithosphere. This green, I don't know कि आपकी वीडियो में दिख रहा है कि नहीं, this green part is part of upper mantle, and that is what called as lithosphere. So what is lithosphere? Lithosphere is part of upper crust, lower crust and small part of upper mantle. This is what called as lithosphere. And this lithosphere is floating over asthenosphere. Again, asthenosphere is part of upper mantle. So here we have upper mantle and this is what lower mantle. Upper mantle and lower mantle. You will get asthenosphere over here. So the asthenosphere is what? The part of, it is the part of upper mantle. Asthenosphere over which the lithosphere floats. Asthenosphere is the source of energy for tectonic movement. It is also called as powerhouse of Earth. Asthenosphere, which is part of upper mantle. So if you see the depth of asthenosphere from the surface up to 400 kilometer. From the surface up to 400 kilometer, we are going to have this asthenosphere. Okay. Asthenosphere. Is it fine? Asthenosphere, over which the lithosphere floats. So asthenosphere, it is called as powerhouse of Earth, and this is the source of energy for tectonic movement. If you see the density, you will find in asthenosphere you happen to have density of 3.5 gram per cc. There is a density of 3.5 gram per cc. Okay, it is a plastic layer. It's not molten. Do remember, आपके दिमाग में molten है. It's a plastic layer. Okay, and asthenosphere के ऊपर lithosphere float करता है. Inside the asthenosphere, there are certain zones where you will find enormously high temperature. Normally in asthenosphere, the temperature is of the range 900 degrees centigrade to 1200 degrees centigrade. This is a normal range of temperature. But yes, there are certain area which is having enormously high temperature. These certain area are called as hot spots. These certain area which is having enormously high temperature are called as hot spots. The temperature of this hot spot may range up to 2000 degrees centigrade to 22,100 degrees centigrade. 2000 degrees centigrade to 2200 degree centigrade. 1000 नहीं बच्चे, फिर से बोल दे रहा हूँ, 2200 degree centigrade. These are called as hot spots. इनको क्या कहा जाता है बच्चे? They are hot spots. Hot spots. इनके बारे में जब प्लेट टेक्टोनिक्स बताऊंगा तब बताऊंगा. 1963 में टूजो विल्सन was the person who gave the term hot spot and the concept of hot spot. You'll find that there is a continuous rise of convectional current taking place, and there is rise of magma also, and that's why these convectional current are responsible for drifting of the lithosphere. And there is continuous rise of magma that is also taking place. Okay, और वहाँ पे divergence हो रहा होता है, and there is formation of what? Mid-oceanic ridge or volcanic eruption. It can be possible. तो यहाँ पे volcanic eruptions भी हो सकते हैं. And these hot spots are just 40 to 50 in the earth. and they are not going to change their position. They remain in asthenosphere. Fine. And these hotspot find its heat from the outer core. From the outer core. So if you see the hotspots, you'll find that the outer core, which is what? Liquid in nature. No? This outer core, which is liquid in nature, having temperature of 4000 डिग्री सेंटीग्रेड. यहां से क्या होता है बच्चे, मेंटल में कुछ ऐसी चट्टानें होती हैं, दे आर मोर कंडक्टिंग. सो ड्यू टू कंडक्शन व्हाट हैपन, there is heat that start traveling through mental and reaching to asthenosphere. And when this rocks are conducting this heat, these rocks get molten and it form a mushroom shape magma accumulation inside the asthenosphere. And pluming of this magma is also known as mental plumes. So in hotspot को और भी क्या नाम दिया जाता है बच्चे? They are also called as mental plume. How the mental plumes arise? It is because of dissipation of heat from the outer core. Outer core heat start traveling through the mental by the conducting rock and reaching to asthenosphere in form of mushroom shape magma accumulation. So pluming of magma takes place, and they are not enormous. They are just 40 to 50 in number, and they are not going to change their location. They remain over there and they are going to cause tectonic movement. These are the hotspot or mental plume. These mental plumes are the part of mental. Why it is called as mental plume? Because pluming of heat through mental to asthenosphere. Okay. So asthenosphere is what? It is the पावर हाउस ऑफ अर्थ. यहीं से आपको हीट मिलती है बच्चे. ठीक है. So we have certain discontinuity also. Let me explain those discontinuity. Like you will find moho discontinuity, and this moho discontinuity is present in between crust and mantle. So between crust and mantle, where you will find this moho discontinuity, try to understand. Let me show this moho discontinuity to you, where the meeting of the crust and mantle takes place. Meeting of the crust and mantle. कहाँ हो रहा है बच्चे? ध्यान से देखोगे तो this is going to be the moho discontinuity. Crust and mantle. There is a discontinuity. Discontinuity that means there is not a homogeneous zone. So you'll find moho or mohorvisic discontinuity. Mohorvisic discontinuity you'll find over here. Mohorvisic discontinuity. Then between upper mental and lower mental. Again, in upper mental and lower mental, you happen to have rapidity discontinuity. There is a rapidity discontinuity. This is in upper mental and lower mental. Rapidity discontinuity. Rapidity discontinuity. Fine. Rapidity discontinuity. Mohorvisic, Conrad, first Conrad discontinuity between upper crust and lower crust. Then between crust and mantle there is Mohorvisic discontinuity. Between upper mantle and lower mantle we have rapidity discontinuity. And between mantle and core, this is the point where you will find Gutenberg discontinuity. You will find Gutenberg discontinuity. Gutenberg V-chart discontinuity. This is what? Gutenberg V-chart. Gutenberg discontinuity. And again in core, outer core, this is outer core. and then there is inner core, you will find there is a discontinuity that is called as Lehman discontinuity. Lehman discontinuity. Okay. Lehman discontinuity. If you see the change in temperature in mental, you will find that there is a change in temperature from 900 degree centigrade to 2200 degree centigrade. So there is a change in temperature in mental from 900 degree centigrade to 2200 degree centigrade. If you see the change in density, you will find in mental we happen to have 3.5 gram per cc density, and while we are moving down we happen to have 5.5 gram per cc density. Try to see, this is 5.5 gram, and then you are going in the region which is called as core. This is what core, which can be divided into outer liquid core and inner solid core. Fine. And in outer core, as you cross this Gutenberg discontinuity, you will find that there is enormous rise in density, and this density is 11 gram to 12 gram per cc. Fine. And the temperature ranging from 4000 degrees centigrade to 4500 degrees centigrade. At this very high temperature, outer core is in molten state. It is in liquid state. So outer core is liquid state. Fine. And it is made up of nickel and iron. Outer core is in liquid state, and simultaneously it is churning also. Churning due to rotation of the fine. And due to churning, what happened? There is genesis of electricity and electromagnetic induction result formation of magnetism of the earth. Is it okay? So this outer core is mainly responsible for magnetism around earth. Indeed, inner core is also having ferromagnetic compound. They can produce the magnetism. So core is also responsible for magnetism of the earth, but largely it is due to the outer core. When you are reaching into the core, you will find that the density happened to be 13 gram per cc, and it is made up of iron and nickel. It is made up of more iron. Fine. And the temperature is reaching up to 5300 degrees centigrade, almost equal to the photosphere of the sun. At this much high temperature, the core remain in solid state. This is something which is not understood, because at high temperature, how come the things be in the solid state? Yes, it can be in solid state if there is no alternative. Fine. अगर आपको कोई काम करना है और करना ही है और आपके पास कोई अल्टरनेटिव नहीं है, तो क्या करेंगे? तो आपके संकल्प दृढ़ हो जाते हैं. जब आपके पास विकल्प नहीं होते तो आपको संकल्प की दृढ़ता दिखानी पड़ती है. आपको केवल और केवल यूपीएससी क्वालिफाई करना है. आपके पास कोई अल्टरनेटिव नहीं है तो आप यूपीएससी ही क्वालिफाई करेंगे. ठीक यही चीज कोर के साथ होती है बच्चे. कोर कहता है कि एट दिस वेरी हाई टेम्परेचर गिव मी लेजर टू बी इन लिक्विड स्टेट. मुझे ऐसी फ्रीडम दो कि मैं लिक्विड स्टेट में रहूं. तो अर्थ कहती है सुपर इनकम्बेंट प्रेशर ऑफ ओवरलाइंग रॉक. ये जो तुम्हारे सिर पे इतनी चट्टानें बंधी पड़ी हैं, इनके प्रेशर से तुम चाह के भी लिक्विड स्टेट में नहीं रह सकते. क्योंकि लिक्विड स्टेट में रहने के लिए तुम्हें क्या करना होगा? अपने बीच के मॉलिक्यूल्स की दूरी बढ़ानी होगी. इंटरमॉलिक्यूलर स्पेस ज्यादा करना होगा, जो यहां संभव नहीं है. तुम कर ही नहीं पाओगे. Why? Because you are under a crunching gravity, you are under a crunching superincumbent pressure. Despite of this much high temperature of 5300 degree centigrade, core is in solid state because of superincumbent pressure. This superincumbent pressure doesn't allow core to remain in any other state other than solid state. तो जब कभी परिस्थितियां ऐसी हों कि आपके पास अल्टरनेटिव्स खत्म हो जाएं और एक बचा हो, इसका मतलब भगवान चाह रहा है कि आप उधर जाएं और दृढ़ता के साथ जाएं. So it's time to be solid. Thank you very much for today's class.